Hello, Haley. Thank you for connecting the first.
Hi.
Hello, Hadassah. Thank you for connecting. I will quickly download all things to this computer, and it will take maybe another like 100 seconds, I hope. And then we'll start. So we do have first two speakers, which is good. Let me check if anyone wants to join. Oh, hello, Mara. Nice seeing you connected.
Hello, Professor.
Oh. Hello, hello, Hanmant. We will start shortly. Okay. Sarah is here, so we need the slide here. I was thinking that those who are presenting from online do not necessarily need to be, those slides do not necessarily need to be downloaded to this computer, but those who are in physically need their slides to be here. Sarah. Omar also needs to be here. And while it is downloading, let me check if there are anyone more. Sayed is connecting. Okay. And we have two more. Adam. And the last but not least is okay. Many thanks for coming in person and connecting. I look forward to the session, which is expected to be some very strong, useful, and helpful. Same as last time. The recordings of last time will be available as well. It's just better to administer them together. Where's the camera? Where should it smile to? Yeah, here. So we do have 8 talks. Please try to use 5 minutes. And we are in CHEM676 class. The goal of these meetings is that the practical skills of building molecular models are equally spread among each class. So one person becomes expert in one thing, another in another, and then we educate each other to be sure that we have all the skills. So the numbers are slightly strange, but if we compare yesterday meeting and today meeting, they will go consecutively. So the I think first 3 speakers are connecting from online, right? So let me check if they have privileges to share screen. So first is Haley. Make her co-host. I'll consistently make everyone co-host so that we do not waste time on it in the middle. The NDSU Zoom didn't want to make all of you co-hosts. It was like allowing only half of you to be co-hosts at a time of organizing the meeting. Okay, so questions are very welcome after the talk. The first presenter is Haley Woods. So she will show us a movie made by herself, how to log into the remote server. Haley, please share screen.
Okay, just a second here. Okay, do you see my presentation? Yes.
Yes.
All right. Well, good morning, everyone. My name is Haley Woods, and I am a PhD student in the chemistry department. Today, I'm going to be giving a short talk about MOBA Xterm, more specifically logging into a remote server. So when you log into a remote server, we're going to use the generic line SSH host user, which is like your username, and then @host. So when you open MOBA Xterm, you can start a local terminal, which is like a command line for your local computer. And so in your local terminal, you can initiate your SSH login. So we'll type SSH-X, and we'll get to what that means in a minute. And then your username at the host name. So in this case, we're logging into the Photon server. So our host name is photon.chem.ndsu.edu. And then you'll be prompted to enter a password. Keep in mind that when you enter your password, nothing will appear while you type, mostly for security reasons. And then you can just hit the return button on your keyboard. And if the login was successful, you should see a welcome message for Photon laying out some expectations for the server use. So for some of the terms used in our login, SSH is for secure shell program. That allows a user to log into a remote machine to execute your commands remotely. The X option enables what's known as X11 forwarding. This command executes an X window system, which acts as a graphical user interface for Unix-based systems. This is helpful for us when we try to open programs like Gaussview or other software that we might be using from our MOBA Xterm command line. And that's all. I think we've all done that.
Okay, please join me in thanking Haley. Any questions in class? Any questions online? I have a common suggestion for all of us for the future. You see on the last slide, it is really great. A question is not scientific and not technical. It's more about presentation style. The last slide shows great fonts that we all see from on the screen. But when it was a movie, it was a little small. So when trying to present next time, try to make huge fonts, which sometimes violate our sense of beauty, but make it like maybe 5 lines per screen at all. Otherwise, it will be not visible. And if you are doing screenshots of what you do, you can also use huge fonts there or just focus on a little. But thank you much. It was a great instruction, and special thank you for being in time, which is much appreciated in these short meetings. So please join me in thanking Haley once again. The next speaker is Hadassah, right? Oh, Lola. Let me double check the schedule. Yeah, next presenter is Lola. Lola, would you please share your screen? So we are going to learn more about supercomputer environment that yesterday was introduced by Wenjian. Okay, floor is yours.
My name is Lola, and I'll be speaking about job submission on high performance computing, for this case, CCAST. So CCAST is a high performance computing cluster in NDSU, and it stands for Center for Computationally Assisted Science and Technology. Okay, so you could download something like a POTI or like mobile exam, just like Haley introduced. You could use the SSH or the host name here. I was trying to log into my CCAST using prime.ccast.ndsu.edu. This is where it requests for my name and my password. And the next thing is the welcome message where you start to run your jobs. Sorry if this is a bit too clustered, but so here what I was trying to do is I had a folder where I kept my input file, sort of like where I want my geometries to be. And I had to get a submission script called PBS. PBS means Portable Bash Script. It's used for submitting job to the scheduler. It's sort of like an instruction telling the computer what you want it to do with this .com file. So here is what a PBS script looks like. Generally, it looks the same for different clusters, but depending on which cluster you are working with, it differs. So mostly you see things like -q, which specifies the job that you want, the queue that you want the job to be submitted to. Then you have the part where you specify the number of nodes, the memory required, and the number of processors, depending on the complexity of your job. Here is the maximum wall time, how long you think it would take for the job to get executed. Here is just showing what group I belong to, and here are like instructions telling Gaussian what to do to take in this input file.com, give me back a .log file. So when I'm done getting my PBS script, I would submit using the keyword qsub. Here, I name my PBS script job.pbs. After submitting, I want to check the status of my job, and I could use qstats-u $user. Some people like to type out their entire username. It still works. It would show you the job ID, the queue with which is submitted to, the job name, the number of nodes requested for, the required memory, and the status. R means running. However, sometimes your job could be in the queue. I took this screenshot while I was working yesterday, and I submitted this particular job to the default queue. But it remained in the queue for a while, and I was getting impatient. So I deleted the job using keyword qdel, the job ID. So after I deleted this particular job, I was left with this last one. What I was trying to change the queue with which I was submitting to so that my jobs could go faster. So if you note the job queue here, it says default medium. So I decided that because my job was remaining in the queue for quite a time, I was going to change my job queue. So here is where you see -q default. I changed my job to another queue called Condo 01. That's very specific. That's like very specific queue to like different specific departments. So as a group, you can get assigned to a particular queue so that your job gets done first. So we own this Condo 01. So I submitted my job to this Condo 01 using qsub. I use the qstar to check my status of the job, and I can see that the job is running. with R here. Sometimes I usually, because I submit a lot of jobs, I usually do not remember which one is which. So if I use qstats-fx with the job ID, here I can see the directory with which I'm working from, and I can know exactly which job is running in which particular job ID. Yeah. Thank you.
Please join me in thanking Lola. Any questions in class? No questions? Any questions online? Please speak up or type in the chat line. I see when we upload. Oh, Queenie, thank you for joining our meeting. So Queenie is a veteran of computational chemistry. So quick question to Lola. For those of us who never logged into CCAST and never submitted these jobs, a little bit of philosophy. Who is scheduler? 3 questions. Who is scheduler? What is node? And why we do not run Gaussian on a front node where you log into?
Scheduler, like the name says, it schedules your job for you, like throws in your .com file, what you want to execute, and executes the job for you. That's what I think a scheduler does.
Okay, and why do you submit the jobs through the scheduler on compute nodes rather than on the front node where you log into?
Sorry, I don't know what a front node is. What's a front node?
Okay, then I'll answer myself.
I guess because mainly the front nodes is mainly for like work processing, and it's not specified like by the CCAST faculty. They didn't specify enough, so we can submit. So we need to submit on the queue to go to the nodes that is specified for jobs a long time.
Okay, yeah, thank you much. Did everyone hear and agree? So the cluster is like collection of several hundred nodes. We are directly logged into only one front node, and in order so that it will be not preoccupied by many jobs, we are not running jobs on a central compute node, but the scheduler redistributes jobs over another 100 of compute nodes. And Lola taught us how to practically implement this idea. Any more questions to Lola? Questions 1, questions 2, questions 3. Please join me thanking Lola once again. So next speaker is Hadassah. Hadassah, would you please share screen?
Sure.
Yeah, thank you.
So can everyone hear me?
I can.
Okay. Okay. So, let's see. So I'm going to be going over the basics of uploading and downloading directories and files with SCP. We talked about this about a week ago. So in review, what's SCP? It stands for Secure Copy Protocol. It's a method we can use to transfer files and directories securely between a local computer and a remote one. In the Linux environment, it's also the command line to, it's also the command you can use the command line to securely transfer files. In this class, we've used it and we will use it to transfer files between CCAS computer clusters and our own local computers. So we use it since it's a secure means, as the name suggests, of transferring files. We don't have to worry about connecting the supercomputer to the internet. And it's also useful to transfer files from supercomputer to supercomputer, along with local to supercomputer. In class, we talked about a couple of different methods you can use to transfer files, some that people introduced that are based on like dialog boxes, or such as this screenshot of Windows SCP in the bottom right corner. Are for Windows, there's Windows SCP. For Mac, there's CyberDuck. It's helpful visually because you can drag and drop. The method we discussed in class last week, however, was doing things in the command line. And the advantage of learning how to use the command line is besides the fact that it's versatile between multiple systems, it also enables you to transfer things from supercomputer to supercomputer directly instead of going super to local to super. So I'll focus on talking about the command line. So if you're using mobile Xterm, it can be helpful to have 2 tabs up. You can also use the keyword print working directory to see which directory your files on the supercomputer or local computer are, so you can copy and paste addresses. And that's useful for when you do the SCP command. So here I have an example of downloading from the supercomputer to your local computer a file. I have a screenshot of what the command looks like, and I've also highlighted the different parts of the command. So in light blue, we have SCP, our keyword. In yellow, you'd have your username at supercomputer or whatever the host computer is, colon. Then you have the address of the directory and then the file. And then you have a period, space period after that, which indicates to the command line that you want to copy this file from the supercomputer into your current working directory. So when you do that from your local computer in the command line, if you've connected the host computer, it'll successfully ask you for the password. You can enter that, and then the file you requested will, if it's downloaded successfully, will have like 100% download confirmation. Uploading is very similar. If you're from local to the supercomputer, the difference is you put your local file name prior or to user at supercomputer. And then you just have the directory location, and then that's how you'd end it. And then once again in the command line, you type in the command, you'll have to enter the password. And it'll, if it's successfully transferred, it'll have the file name in the 100%. If you're doing directories or folders, it's very similar syntax to uploading and downloading. I've just had an example here of uploading or downloading a directory from the supercomputer. The difference would be you just have the directory name, so the file name, and a useful command to have is the -R right after SCP. It stands for recursively copy the entire directory. My example here, I made a directory called test downloadable directory, and I downloaded that, and similar to the file case, you end up with the 100% once it's downloaded. So that's what we have in review. So yeah.
Please join me thanking Hadassah. Are there any questions in class? It's clear. Any questions online? Please speak or type in the chat line. It's crystal clear to me. I have a provocative question, and I'm going to provide an answer. What if one expects poor connection and interruptions, and we need to transfer like a terabyte or several gigabytes of data, like big directory? Did anyone in the class had an idea what to do if one needs to transfer big files and we may get interruption in the middle?
It will be better if you're going to make the file in the terminal as a zip file and then download it. It will reduce the size. Okay.
Yeah, thank you, Sarah. It's a good idea. There is another thing, another command, rsync, RSYNC, and it is used in the same format as SCP, but it anticipates that the transmission can be interrupted, and it makes an additional record each like millisecond where we are in the way of transmitting, and if the transmission is interrupted, one executes the same command, and instead of starting over, it continues from where it left. So just in case if you need to transfer big files, you have an idea where to look. So Excellent talk. I think it is really useful, and we will use this skill. So do not neglect the knowledge that Hadassah has communicated. It's critically important, especially for last 2 months. So we can run Gaussian without it, but when we will be working with WASP, it will be a survival skill. Thanks once again to Hadassah. The next presenter is Hanmant. So please consider to share your screen. Okay, and now we are going to a pleasant part of making drawings.
So hello everyone, my name is Hanmant, and today I'm going to present a topic on building atomic model in Gaussview. So basically Gaussview provides the graphical user interface and which assists you to prepare the input files for the Gaussian submission. The Gaussview also used to prepare large molecules which we then analyzed in the Gaussian. Also, in Gaussview, we can import the PDB files, which is commonly used molecular format, which is used for the molecular modeling purpose. So now for this molecular building, I considered aminophenyl butyric acid for the demonstration. So before launching the Gaussview, first we need to log into the server. So already Heli told us that how do we to log into the online user server. So for that we use the MobaXtrom. So where we use these commands to log in. So once we log into this server, then we need to access the directory. So for that we use different commands where we use pwd for checking or accessing the working directory. So in the working directory, we need to check the files. That time we use the ls command. And once you want to change the directory, that time we use the cd command. So if you want to create another directory, that time we use the mkdir, that is, this is the command, and we can create another folder or directory for our molecular preparation. So here I created the one directory, my presentation directory, and in that presentation directory I prepare the molecule. So now by using this command gview.exe add, and so by using this command I launch the Gaussview. So once I launch the Gaussview, that time I that time these two windows are pop up. First window is a control panel and another window is a molecular view window. So in the control panel we will see the different toolboxes, and in the viewer window we can just click it and we will create the molecule. So for user-friendly interface, I selected the builder toolbar. So where we have to go to the control panel and just click on the view. Then we select the builder option where we will get the builder plate and builder palette. And in this builder palette, what we will see the different fragments which we use to create the molecule. And as well as once we created, we need to, if we need to modify the molecule, that time we use different options like bond, which will modify the displacement, angle, dihedrals, and also we will use the cleanup option to optimize the created molecule. So in the first step for our molecule, what I did, I created the benzene ring. So for that, I used the ring fragment from the builder palette. So once I click on the builder palette, what happened? This window will pop up. So in this window, different ring fragments are what I will see. So here, benzene ring fragment I selected for my molecule. So once I clicked on the viewer window, the builder, the benzene molecule, which we can see on the viewer window. So after creating that molecule, in the next step, what I did, I attached the nitrogen molecule to the one end of the benzene ring. So for that, once again, what I did, I click on the element fragment from the builder palette. So once I clicked on the element fragment, that time this element fragment tool window will pop up. So here from this from this, here we see different types of elements, out of which I selected the nitrogen element. So once I select the nitrogen element, so for the nitrogen element, I can see the different options of the arrangements, where I selected the nitrogen tetravalent and I clicked on the one end of the benzene ring where hydrogen atom is there and where I can get the arrangement what I expected. So when I am selecting and when we are attaching the element, that time we just have to consider the hot elements. Hot elements are the element which we see in the blue, light blue color. So here nitrogen element which we want to attach, that's why we consider nitrogen as a hot element. If you want to attach hydrogen, just click on it and it will be the hot element for your arrangement. So in the next step, what I need to do, I need to attach the carbon chain to the another end of the benzene ring. So for that, once again, I clicked on the element fragment, and once I clicked it, same window will show. And out of instead of nitrogen, now I just clicked on the carbon, where for the carbon I just see the different fragments. Out of that, I selected the carbon tetrahedral, which is needed for my molecule preparation. So at another end on hydrogen atom, once I click this fragment, it will show this, and it will show this arrangement, and by clicking one by one I will get the final arrangement or final chain for the carbon. So at the end, what I need to do, I just have to add the carboxylic group to this chain. So for that, I clicked on the another fragment, that is a ring group fragment. Once I clicked it, I will see different ring group fragment like a formyl, ethyl, and carboxyl. So out of which I selected the carboxyl fragment. So once I clicked at the end of the carbon ring, and I will get the carboxyl arrangement. And once I get the final molecular structure, I will click on the cleanup. So I will optimize this geometry in some way. It is not finally optimized, but in some way we will get the optimized geometry of this molecule. So once we optimize this geometry, we need to save the molecule. So for that, once again, we will go to the control panel. We will click on the file and we will click on the save option. So once we click on the save, we will see the different option for the saving the file. So here we can choose any format which you want for the preparation or for the next procedure. So here I selected the COM format, and once I clicked on it, it will get saved. So to see the files, once again I open the mobile Xterm, and where I input this command, and where I can see the total details of the molecule what we have created. Thank you. Any question?
Please join me thanking Hemant. Any questions in class? Any questions online? I think it was very clear, and I especially like that it was a goal-achieving strategy to build specific molecule. So for the sake of time, I think we need to speed up. We have like 6 talks for 25 minutes. Next presenter is Sarah. And she is presenting from in class. Please confirm if you see her slides. Right? Please, does everyone see her slides?
Yes.
Okay, yeah, thank you, Hadassah. Here's your microphone. Please try to speak into it.
Hello, everyone. So we're gonna continue on what Haman just presented. So he just draw structures. And once you're done drawing structure, like my structure here is C2H2, the first very quick optimization can be just by clicking the cleaning tool here, and you will get a quick cleaning for your structure by quickly optimize it. If you want to change, or if you find your structure is not as optimized as you hope, you can go to File and then go to Preferences and then choose Clean Controls. And from there, you can adjust the criteria or the performance of the clean tool based on your system. So you can increase the tolerance, increase the time, Or maybe if your system is very large, you can increase view update times so your laptop won't crash if you have it on a desktop or something like that. And also, in some cases in large molecules, you need to set the soft angle as 0 and other parameters as 0. So your system converge. For more details, the help button can get you to the page with more details and more help in adjusting this tool. Okay, this is just a quick, not of course professional optimization. So you need to continue to a higher level of theory optimization. Here, you go to calculate and then Gaussian setup, and then from the job tool you choose different options. So here, for only optimization, you're gonna choose optimization, but if you want to do optimization followed by a frequency, you're gonna choose this option. And if you're gonna use optimization with concentrating coordinate, maybe angle, bond, dihedral angle, and so on, you can use the scan. But now we're gonna focus on the just a standard optimization. And then in the method tab, you choose what you're looking for, the ground state or transition state. And then we choose the theory, which is here is the DFT, and then you choose the basis set, and after that you choose if you want to apply diffusion or polarization to your basis set. Finally, you set your charge and the spin. So here my charge is just 0 and I'm using just single state. After that, I prefer setting the titles so I know what is running for which molecule and what kind of simulation I'm doing. So here is C2H2 OBT. After that, the link 0. This one I prefer, it's more easier to write down on the input file, but if you want to select from here, you can set the memory, the processes, checkpoints, and if you're going from previous checkpoint file optimization, you choose from the old check file here. And then the general tab, it has some important stuff. So maybe you can write your input file coordinates in the PTB data format or Cartesian. And also you can write or don't write the connectivity. You can ignore symmetry if you're going to simulate maybe polymers or something like that. And if you have very difficult SCCF conversions, you can choose the quadratical conversion. SCCF part is very time consuming. And also, of course, if you're starting from previous completed simulation or previous checkpoint data, you can select it from here, or you can choose another OBT equal restart, which is not the scenario here. So let's continue. Once you're done, just go to the preview here and double check your input file. Is it okay or not? Gaussian view is very good, but not all the options are available. So sometimes you need to save it using edit and then save and then write down what you want. But make sure you have your hashtag in the command and in the theory command before the keywords. And finally, the last the last of the output file should be a blank line. And for the printing level, you can add V for extensive printing or P for pre-printing and saving the size of your output from geometry optimization. Yeah, thank you very much.
Sarah, any question from the audience in class? Any questions online?
So this is just very, very brief optimization, like more advances we need. So guys, this is just a very, very standard optimization. If you need more serious optimization or complexity, it will be very useful if you check the Gaussian website. It has a lot of details.
Okay, yeah. Please join me thanking Sarah once again. And we do have the next speaker also in class. So Umar is, to my understanding, is going to continue teaching us how to modify models in Gaussview. So maybe the order of presentation should have swapped first. Okay, so here is a microphone.
Okay. Okay, so I'm Umar Aslam, and I will try to highlight some features of Gaussview, such as distance and angles. So to modify the distance, we have to click on the modify bond command that is available in the second row, as you can see in the icon. And we can get this command from the builder drop-down menu as well. So when we click on two atoms for which we are going to change the distance, so this menu is basically appeared. This menu appears, and for that menu, this is the detailed description in which we have the bond type. We can modify the bond type from none to many as per need. Then we have different bond. You can say, like, we can modify the distance of the whole for the whole group for only one atom. We can modify the distance from, you can say, for both atoms, or we can just modify one of them by keeping fixed the other one. And then finally, we have this bar. We can rotate it along the scale. So it's also helpful to modify the distance. And we can also put our desired value in that box. So it's going to help it as well. So these are some examples that I have done to highlight the bond types. And you can see it represents there isn't any bond in that molecule, and it has almost 3 bonds. So you can see the description below to that figures. So when we talk about the modification distance, the same menu is used for that. And here I have translated the group 1. Actually, this is also the group 1 and also the atom, because we do not have any other atoms that are attached to that. And however, I have fixed the atom 2. But in the next example, I have fixed the atom 1 and I have translated the atom 2. So here I haven't translated the whole group. So this is only translate the atom only. So you can see a comparison through these figures. Okay, so the second is the angles that is just adjacent to the bond, modify bond command. And this is the menu for that. And for example, this is our original molecule. So to modify the angles, we have to click on 3 atoms, as I have mentioned here. These are almost same. So here you can see, here I have rotated the atom 1 and 3 while keeping the second atom is fixed. And similarly, here I have fixed second and third. I rotated the first atom, then first and second are fixed, and I have translated the whole group atom 2. So it's, you can say, change its position from that to that. And similarly, I have the last one is atom 2 and 3 are fixed. However, I have rotated the atom 1. So you can see it is changed its position from that to that side. So finally, the dihedral angles. For that, I have to click on 4 atoms, as I have done here. So this is like I have changed its symmetry as a comparison between the previous examples. So here I have rotated both groups. We can rotate both groups. We can rotate, you can see, 1 atom. And then in the third example, I have rotated group atom 4, but I have remained with the first one is fixed. So you can see the rotation by clicking on these options. Yep, that's it.
Okay, please, Jeremy, thank you. Sarah, do you have questions? No. Are there any questions online? If no, please join me thanking Umar once again. So the next presenter should be Amir, right? So please share your screen.
Can you enable me to share screen, please?
I will try. You should be good to go.
Sounds good. Can you see my screen now?
Yes.
Okay. So, hello everyone, my name is Amir, and today I want to give you a brief introduction about the software OpenBabble and how to use it in command line. So basically OpenBabble, or simply Babble, is a software that can do multiple different things for you, such as calculating fingerprints and descriptors or optimizing molecules for you. And but the most important thing is that it is able to convert different types of file formats together. For example, from PDB to Mol2, from SDF to Mol, and etc. And that is the most important usage of this software. And beside that, it has some, it can be used through the GUI version or the command line. So why do we have to use OpenBabble? So the thing is that there are multiple different softwares that we use in computational chemistry, and each of these softwares have their own specific types of format. For example, the software Gaussview that we're working with, it works with like .com files, or if you use HyperChem, it uses another type of file. And then you will essentially have to be able to convert these different types of files together. For example, PDB is the protein database. And then if you're working with proteins, you might have to like work with these type of data. And then if you want to like optimize it in Gaussview, then you have to like convert it to .com format. So basically OpenBabble will enable you to do these things. And then another advantage of this software is that it will enable you to convert many files at the same time. And so here's a quick snapshot of the software, the GUI version, basically. So on the, let me just turn on my cursor real quick. Okay, so on the left side, you will input your file here, and then on this side, on the right side, you will select the format that you want to convert to, and then you simply click on convert, and it will give you the results. It will print it here, and also you can save it into an output file as well. And then there are different options here as well, like deleting some hydrogens, adding explicit hydrogens, or there are also you are enabled to generate 3D coordinates for some files. By default, it would not generate those 3D coordinates, but you can click on this one, and then it will provide you with the 2D or 3D coordinates of that file. And yeah, there are different options that you can select beside converting. And so if you want to use this software in command line, there are, it's simply, so you type in OBabble, your input file, -o, and the output file. And then by choosing this format, for example, if you just type in .pdb, it will convert .xyz to .pdb, and this is the name of the output file. And so there, if you add these, like, so if you want to remove or add hydrogens, then you're supposed to put a -d for and -h. So if you do -h, and then it will add explicit hydrogens. If you do -d, it will remove hydrogens. And to generate 3D coordinates, you can do --gen 3D. And then other comments can be found at the documentation of OpenBabble through this link. If you just Google it, it will pop up. And so the most important thing is that this is a free software, and it's available for all operation systems like Windows, Linux, and Mac OS. So you can easily download it, or you can also use it on CCAS and through the command line. And thank you for your attention.
Just join me in thanking Amir. Any questions? Yes.
So Amir, what's the difference from the Babble and OBabble when we write it? Like what the order difference in them?
So you can use either ways. If you do OBabble, then you have to provide this -o here. But if you do Babble, you can just type in your input and output.
Only syntax?
I believe so, yeah. I think the syntax are like, but they do pretty much the same thing.
Thank you. In which circumstances command line is better? When it is more beneficial than running it in the mouse operated format?
So I believe if you want to use it on the supercomputer, then we have to use the command line format.
Yes, correct. then we save time on downloading and uploading intermediate files.
Exactly.
And it is exactly what we plan to do. Okay, please join me thanking Amir once again. And we have two more presenters on other alternative pieces of software that do similar job to Gaussian, just as a backup. So next presenter is Adam. Adam, would you please share screen?
Yeah, one moment.
Okay. I think I need to change. Just a second. Co-host. Yes, I think now you're a co-host.
Okay. All right. Go. Okay. I'm going to be talking about Avogadro. It's another molecular modeling software. It's pretty easy to use. It's very, very similar to Gaussian, but I'll kind of talk about that. So it's freeware. It's for Windows, Mac and Linux. You can download it from that link in the documentations and that second link there. On startup, you'll kind of see a screen that looks like this. You can see that kind of toolbar that I've circled in red. That's mostly just for navigating and
Would you please
drawing.
enable camera if possible?
Oh, I'm so sorry. I totally forgot. Yeah, that's this is essentially just for navigating and drawing molecules. So you can see that kind of drop-down menu right here. It says carbon 6. You can just choose your element. You can choose, of course, any element that you want, and you can click and kind of drag to create bonds and stuff like that. Yeah, so I'll mostly be talking about the toolbar at the top. In file, everything is kind of normal. You can create new files and open old files, but you can also import and export a lot of things. So you can import mostly like fragments of molecules, like you can get proteins and crystal structures that are in the database that actually come with the installation of Avogadro. And you mostly export things as graphics, like vector graphics, and you can make like a ray traced vector graphic as well. Okay, yeah. So view mostly, I'll be talking about projection and properties. So in projection, you can just change, I guess, the projection of your molecule. But under properties, you can fine tweak specific structural properties like the atom identity, the bond angle specifically. I think somebody else after me will talk about that, and etc. Yeah, so you can use the build to kind of insert, I guess, molecules themselves. You're going to insert like DNA fragments, of course. You can insert molecules from SMILES strings, which I think we've done before. And also construct nanotubes, which was in that one homework we did. Yeah, and you can also make these crystal supercells based on your desired parameters. Yeah, there are a bunch of extensions that you can use. I think the one that is the most important to us is the Gaussian extension. So essentially, you can create like an output, or sorry, you can generate like an input file for Gaussview, which you can load into Gaussview to compute energies and geometries and stuff. Yeah, I think this is really useful because you don't have to do everything in the photon server. But yeah, you can get a lot done at once. And you can, of course, save this file as any common molecule format, just as we've kind of discussed before, as you can do in Gaussview as well. All right, questions?
So join me in thanking Adam. Any questions in class? Umar, Sarah? Any questions online? Gaussview, I'm trying to generate a question, although I'm not well prepared for it. So when we draw molecules in Gaussview, it automatically set preferred bond lengths and angles. It kind of automatically guesses reasonable chemical structures. Does Avogadro makes this educated guess while you clicking, or you need to adjust, optimize, and specify? Like, what is your experience?
Yeah, you need to kind of manually adjust it. When you click and you drag to kind of create a bond between two molecules, or even create just a new molecule bound to another one, or a new atom bound to another atom, how far you drag will specify the bond length. So you would have to take extra care, I guess, to go in and actually adjust it.
Yeah, thank you, Adam. Sarah wants to add.
So there's a tool in the third one from the right in the red box you highlighted. So that one, once you select after building like very kind of off molecule, once you select on it, no, the E, and then this one, and just select the force field. It's very quick optimization. It's similar to the clean in Gaussian. So it's very helpful.
Yeah, many thanks, Sarah. So on one hand, Gaussian immediately makes right bonds. On another, by Adam, I like how he formulated, by placing clicking far or close, one can immediately control distance. And if one designs a molecule that is not fitting the standards, if one designs something really new, this versatility can be useful. More questions to Adam. Questions 1, questions 2, questions 3. Let's thank Adam once again. Adam, you can stop sharing. Thank you. And the last but not least is Amara. Amara, would you please share your screen?
Yes.
Okay, yeah.
Hello, as Adam Adam explained about the Avogadro. So I will directly start how to build an atomic model. Yeah. So I will directly start how to build an atomic model in Avogadro. When you open an Avogadro, there you pop up the window in which when you click on the window, it will automatically like draw the atom with the and carbon atom. That is default. By default, it's like the carbon atom. You can change the display setting through the display here, display type, and here there are many different display types that you can choose whatever you want. And if you want to change the element type, so there is a drawing method. You can go on the draw setting, and then you can change the elements. There are many elements that you can change, but if you want some other element, so you can use the periodic table where you can get any element but want. And you can also use the single, double, or triple bond. You can adjust the hydrogen. If you will adjust the hydrogen, it will automatically adjust, but you can uncheck this box and you can add it manually. So after drawing the model, you can optimize the atomic model. Here, when you go to that menu, either that is the auto optimization setting, there are 3, 4, 4 speed that are present in the Avogadro. You can select whatever you want. You can select the steps that you need for optimization, the algorithm, and you can also fix the atom that you don't want to move during the optimization. So here is the you can go at extension and the molecular mechanics, and here is the option to fix the selected atoms. When you click on that, and after the atom, it will be selected and it will not move during the optimization. So then you can start the optimization and it will optimize your model, and it will give the optimization energy of the model. After that, you can also measure the bond length, distance, and angles through this software. Here you go to that ruler, and after that you need to select the to measure. When you select 2 atoms, it will give you the distance. And when you select 3 atoms, the angle and distance. And when you select the 4 atoms, then it will give you the dihedral. So it will differentiate by different colors which atom you want to select. It will, by different color, you can select the bond distance. So after that, you can go to the, you can also change your torsion angle by go to the bond setter manipulation setting, and here you can select a plane, and then you can move or drag the atom to rotate the plane. So there is the also the setting. You can use the cursor to move the atom, or you can also use some XYZ axis. So you can rotate the atom through this option also. Here you can insert, there are already many fragments that are already installed in the software. You can just put it up, like there are a lot of fragments, peptides, DNA, just like here, there is a list of all the fragments that are present already in the Avogadro. There is the option of peptides that you can insert through this option. And that is the option of nanotube builder in Avogadro. You click that to the chiral indices and the length of the nanotube, and also you need to the here you can check the properties. You go to the view and then properties, the number of bonds, atoms, and energies, chemical formula, and you can check these properties through the software. This is the option. You can build the model and use this model as input for the Gaussian and for the LAMP software also. But this is very initial, like you want select for the file of LAMP or Gaussian. So here it's the save file, like you can save any by using the any extension, and it's all the compatible with the Avogadro format. Thank you.
Please join me in thanking Amara. Other questions in class? Other questions online? I do not have questions, but I really like the new functionality I learned from Amara. I think it is useful things, especially about building polymers. It should be useful. So last chance to ask questions. Questions 1, questions 2, questions 3. Please join me in thanking Amara once again. So the session is done. Congratulations on completing this important step. So this is considered as first midterm. All presenters did tremendous work and get grade A for the midterm. So you are progressing well towards completing the class. And I look forward to meet you in the lab tomorrow evening. We will need to make plan for next week and a half because there will be some missed lectures, and we need to make a brainstorming plan of compensating it in some or another way. So okay, but congratulations on completing, and looking forward to see you tomorrow. Meeting is done. Everyone is welcome to leave or exit the connection. I'll stay here to answer any questions, if any.
Thank you. Thank you, Professor.
Thank you.